Welcome to the world of AIMES, where cutting-edge technology meets strategic innovation. In this video, we'll take you on a journey through the powerful capabilities of AIMES, the ultimate tool for visionary leaders. AIMES is a powerful tool that enables management to develop optimal strategies and achieve market success. It allows users to create financial models across various scenarios and optimize model parameters to deliver the maximum possible results within existing micro and macroeconomic constraints. Our platform starts with a visual editor, which makes model building collaborative, transparent, and auditable. It continues with the scenario manager, enabling you to handle numerous scenarios without needing to edit the model. The most fascinating component is the optimization engine, capable of finding the best parameters for your model across all given scenarios. Together, these elements create a powerful functionality that elevates you to the cornerstone of your company's competitive advantage. Now let's take a deep dive into the key features and components that will give you a thorough understanding of how this can revolutionize your business strategies. In this session, we'll guide you through the process of building a financial model from the ground up, simulating various scenarios and optimizing parameters to meet certain business objectives while effectively navigating real-world constraints. Consider the case of an e-commerce company that operates in the online retail space. The business value chain is presented on the screen as a mind map. The company's revenue is influenced by several key factors, including the number of customers, average order value, and purchase frequency. To drive growth, management invests in advertising to attract new customers. The influx of new customers is largely determined by the conversion rate of website traffic. Additionally, the company undertakes promotional activities that incur costs with the goal of increasing the frequency of customer orders. However, a significant challenge arises: optimizing the marketing budget to enhance key performance indicators such as revenue or profit margin. To further accelerate growth, the company has the option to utilize borrowed capital. It is crucial, however, to maintain financial stability by ensuring that the debt-to-equity ratio remains below 2. While the company is currently performing well, management faces a pivotal question: can they achieve even better results? And is there a more effective strategy available? This is where AIMES proves invaluable. By developing a comprehensive model of this e-commerce business, we can identify optimal strategies for management to implement, ultimately driving improved performance and sustainable growth. Before solving this problem with AIMES, we want to illustrate how an attempt to address it using a traditional spreadsheet tool might look. Our financial modeling expert constructed the model you see on the screen, which accurately reflects the company's current strategy. However, as you can see, verifying the correctness of formulas and data connections in such a model can be challenging for someone encountering it for the first time. Additionally, the expert had to spend a significant amount of time manually adjusting the model's parameters before achieving any meaningful results. Despite these efforts, the expert was unable to identify strategies that were demonstrably better than the company's existing approach. Furthermore, even for the strategies he did manage to find, he could not prove their optimality in any meaningful way. Let's solve this problem together using AIMES. The first step is to create a new project. Once that's done, a new sheet will be generated where the model will be constructed. For this new sheet, you need to select the calculation period for the model. This can be defined using absolute dates with a frequency of 1 day, month, quarter, or year, or simply as a number of periods. For instance, let's set the model sampling frequency to 1 quarter and choose the project period from the first quarter of 2025 to the fourth quarter of 2027. After making these selections, click the Create Sheet button, and you will be directed to the modeling board, which consists of a grid of cells used to create calculation and data nodes, the fundamental elements of our model. At this stage, data and formulas are not required. We focus on modeling the logic first. As an example, let's create a revenue node and designate its type as formula, indicating that it will be calculated later using a specific formula. This node will compute the revenue generated from sales to our company's customers. Next, this node should be linked to a new node called number of customers, as the number of customers directly impacts business revenue. We can create this connection by clicking on the Connect To field of the revenue node and linking it to any available cell. Name the new node Number of Customers. This node will also be of the formula type and will calculate the total number of customers for our company. Next, let's create two more nodes: purchase frequency and average order value. Connect both nodes to the revenue node and set their types to data source, as this information will be sourced from other company systems rather than calculated within the model. The first node will track the number of purchases made by a single client during each project interval, while the second will record the average purchase value per client in those intervals. No data is needed at this point. Let's create another link from the number of customers node to a new node called new customers and set its type to formula. This node will calculate the number of new customers acquired in each period. Additionally, let's create a churn rate node, which will track customer attrition. Since we receive churn data from the CRM system, this node will be of the data source type. In a similar manner, we complete the entire model. To save time, the model has already been constructed and consists of a set of interconnected nodes with specific types. Once the logic of the model is built, node types and connections are set, one can move on to setting the calculation formulas and data in the nodes. In data nodes, you can set data in a form of an item or a list. Item is a structure with one row of data and no title, and the list is a number of rows with the data and the corresponding titles. Let's create a list data with titles and corresponding values over the time period. In the average order value node, let's set different values for different rows and assign the corresponding titles to the rows, being product A, product B, and product C. As you can see, doing this is as easy as in any known spreadsheet tool. For ease in setting equations within formula nodes, there is a visual editor that enables you to create and display formulas visually, requiring only basic school-level mathematics knowledge. Let's configure the equation for the revenue node. To do this, enter the revenue node, begin typing the names of the relevant nodes, select the desired node from the list. You can also apply the necessary arithmetic operations or functions available in the equation editor. After the formula is written, you can calculate it and obtain the result by clicking the play button in the right corner. The calculated result appears at the bottom of the page. AIMES allows you to work with nodes time settings, just like in finance textbooks. Suppose you need to reference a node's previous value. Each node has time settings for this purpose. In our example, let's navigate to the node number of visitors. In this node, we are going to set up time setting for the node advertising expenses. Right-click the node, select the time settings, select if you want to fix this value or make it relative. Depending on the choice, AIMES will either iterate the value over time, called relative, or always refer to the value in the past, called fixed. Selecting previous values, make sure these values are available in the data node for the corresponding period. In our case, let's select time equal to -1 in a relative mode. This way, AIMES will automatically use the previous value of this node at each point in time to calculate the formula. This feature is convenient because it eliminates the need to manually care about the time compared to the spreadsheet tools. In AIMES, these settings are easy and convenient. If you are familiar with Python programming and can write simple scripts, you can utilize the calculation node type called Python. This feature significantly enhances your capabilities by allowing you to create loops, conditional statements, or even machine learning models. Let's see what is inside the Python node called number of customers. We see the Python editor field where one can write Python code. Let's insert the pre-written code for this node that has certain conditions, and that is requesting data from some other nodes and execute the calculation. Similar to the formula node, the results of the calculation, of course if there are no errors in the code, will appear at the bottom of the page. Once the model logic is established and all formulas and data within the nodes are defined, you can calculate the model to ensure accuracy and confirm that there are no errors. With our model now calculated, we can proceed to scenario modeling. Scenario modeling module enables you to create different versions of data for data nodes and build various scenarios using these versions. Let's explore this process together. AIMES allows you to create an unlimited number of scenarios for model calculations. To do this, navigate to the Scenario Modeling module. By default, you'll see the base scenario along with all the data nodes used in the model's calculation. The versions of these data nodes define each scenario. Let's enhance the base scenario by adding 2 more scenarios, optimistic and pessimistic, using the base scenario as a foundation. In the optimistic scenario, we'll increase the conversion rate to 30%. While in the pessimistic scenario, we'll decrease it to 10%. Once you've set the values for all data nodes in each scenario, you can calculate all 3 scenarios, allowing us to proceed with building the report. Once the model is calculated across different scenarios, you can create straightforward visual reports to compare the results or download the calculation outcomes as a file. AIMES provides a module specifically for building these visual reports. The visual reporting model allows us to visualize all the nodes available in the system. For example, let's look at the graphs of such indicators as revenue or net income. After calculating the scenarios and looking through the reports, we proceed to the most intriguing phase, searching for the optimal parameters of our proposed model. The aim of optimization is to identify control actions that enable us to achieve the business's target parameters while adhering to specific constraints. Let's define the optimization parameters together. First, the system prompts us to select target variables for optimization. We'll choose number of customers and aim to maximize their count by the 3rd year. Additionally, we want to maximize not just the total number of customers, but also their average throughout the entire year. We will also select accumulated free cash flow and aim to maximize this metric in the last quarter of the 3rd year. With target variables defined, let's set constraints specific to our business. We'll choose equity and ensure it remains greater than 0 throughout the project. Additionally, we'll select debt-to-equity ratio and maintain it between 0 and 2 during the project's duration. Now that constraints are established, let's configure the controls. In this section, we select metrics we can manage. For our case, we'll focus on nodes responsible for marketing costs, advertising expenses, and promotion expenses. Since budgets cannot be negative or unlimited, we'll set a range from 0 to $500,000 for both nodes. This completes the setup of the optimization parameters, and we can now begin the calculation. The time required to optimize different models varies based on factors such as model complexity, project duration, and the number of optimization parameters. In our case, optimizing the model took only 10 minutes. Let's review the results. Through the optimization process, we obtained 100 solutions that form the Pareto front. The relationship between our objectives is nonlinear, which adds complexity to solving these problems manually. This collection represents solutions, each optimal in its own way. Each point on the graph corresponds to an optimal set of actions. Let's analyze these solutions. On the left-hand side, we can see 3 distinct strategies that have been selected from the Pareto front, and will now be compared in terms of their outcomes related to customers, revenue, net income, cumulative free cash flow, and equity, all relative to the base strategy the company has been running. On the right-hand side, we can observe the optimal control actions that the company needs to implement in order to execute one of the selected strategies effectively. Let's compare these strategies. The maximum customers strategy significantly increases the customer base by over 300% compared to the base strategy. However, despite this increase in customers and more than tripling the revenue, it results in a negative cumulative free cash flow, indicating that the costs associated with acquiring such a large number of customers outweigh the benefits in terms of cash flow. The positive cumulative free cash flow strategy focuses on maintaining a positive cash flow with an increase of nearly 180% in customers compared to the base strategy. It achieves a small positive cumulative free cash flow and more than doubles the revenue and net income. However, its equity is slightly lower than some other strategies. The maximum cumulative free cash flow strategy appears to be the most financially robust option. It increases the customer base by about 25% and boosts revenue by approximately 28%. This strategy achieves the highest net income, which is more than triple that of the base strategy, and results in a substantial positive cumulative free cash flow. Additionally, it leads to an equity value that is nearly 47% higher than the base strategy. AIMES allowed us to find these strategies in just 10 minutes, whereas it would take humans many days, if not longer, if at all, to arrive at similar results and strategies. This demonstrates how powerful AIMES is as a tool for complex analysis and decision-making. It stands out as the one and only solution capable of performing this kind of analysis efficiently and effectively. Thank you for your interest in AIMES. Now it's your turn to dive in. Head over to aimestech.com, register, and start building your own model to discover its optimal parameters today. If you have any questions, feel free to reach out through our website or use the contact information provided. We can't wait to see what you'll create with AIMES.